Okay, this is all very good, but we'll run into a very more abstract issue here of circularity. So can you see some form of circularity here? Some cycle that will prevent Java from actually allowing us to enter this code? So far you've been creating multiple objects with you've been composing types together, you've been writing programs with multiple types, okay? And you've got a program with multiple types. I showed you 2 types. And I'm saying there's a type circularity here. So some types depend on other types, right? One type may refer to another type. So which type depends on which type here? Java will make sure that when a type is being created, and that type is being created in terms of another type, the independent type should exist at that time, should have a name. So when I'm writing my observable counter, I need a counter observer defined. When I'm writing my counter observer, I need the observable counter. So have you run into some real problem here? When I type this, it says, sorry, underlines this. I start typing this, that underlines this. I'm stuck. Or am I? So we don't instantiate class interfaces. We write them and compile them. And one has to exist before the other, right? So even if you use threads, I had one program, one thread doing this, one thread doing this. Each thread would say, I don't have the other. So we have a chicken and egg kind of problem, right? Some circularity problem.
Does the compiler gather the names of all interfaces and create the interfaces just with their names before it asks the methods?
It could do that. You can create an interface and then update the interface. So you can create that in 2 stages or multiple stages. You know that, right? I give you an interface, you write one method, you compile it, you write another method, you can compile it. So that seems to be the key here. Is that the fact that I can create an interface in multiple stages, is that going to help us? Just empty interface. We know interfaces can be empty. Remember the test first solution approach that I talked about? The tester had to come before the object it was testing. Well, not quite. We wrote the object with all its stubs. Where the stubs had nothing. And the tester could work in terms of the stubs, and then you gradually fill the stubs up. So what we can do is create our counter observer with nothing in it. It doesn't refer to the counter. And actually, I've got a slide, I think, on that. So cannot compile observable counter without counter observer and vice versa. There's a circularity. And I could do this the following. I could create the observable counter without any update, without the registration method. Write the counter observer fully, and then go and add something to the observable counter. Okay, so now added. And the basic point is that you can recompile previously created object. Okay, so this is the problem you will run into, and this is the way to avoid the problem.
Yeah. But does Eclipse automatically account for this? Because I don't think I've ever run into this using Eclipse.
You never run into this using Eclipse because you've never created 2 types yourself that depend on each other. Now you will. Okay? Or if you created them in stages, so it didn't find it. But yes, if you go and type this the way I'd shown it earlier, Eclipse will give you tools. Okay, originally what we did was the following. I started writing my observable counter. Okay, I didn't have a counter observer at that time. I put counter observer here and it underlined and said, sorry. I tried compiling 1, 2, 5 times. Each time it complained and said, I can't compile. Okay, so I start writing this particular piece. So it's not compiled. It's not known, and now I start compiling this. and it says, sorry, observable counter doesn't exist because I have not compiled it. It's not a compiled unit. Okay, legally compiled unit. So what do? I create this. I went and created this as a legally compiled unit without this particular method. So it's now a legally compiled unit that can be referred here. And now I can take the legally compiled unit and go and add more stuff to it. And it becomes an update of the legally compiled.
And then, like, how do we track where you do that?
You just save it, and automatically compiles it. Yeah. No, to have circular types, is that a fault? No, we need it here. It's not a fault at all. It's, you know.
Like, not like what a particular type of fault, but like having the fact that you can't compile particular types, like the fact that you kind of like don't correct.
Well, what you're saying is, why did Eclipse complain that there was no counter observer at that time? It should just say, by the time I run the program, it'll exist. Trust me.
Yeah, like one.
At runtime, you'll get all these strange errors then. So it's trying to make sure at compile time that you don't run into a problem. Otherwise, it says, sorry, type not found at runtime. Actually, Eclipse will sometimes give you the message, sorry, I can't find this type. That's because of some errors in it, some Java version incompatibility. You will sometimes get that error. You don't want to get that error, ever.
Because the designers personally do this automatically do this what they have to do. They wanted to say like, instead of happening error because they just do something like putting the code.
Yeah.
So when Eclipse compiles it, it doesn't recompile the entire program.
That's right. Eclipse is doing incremental compilation.
Okay.
That is what is.
What if you're compiling with a non-incremental?
So if you're doing a non-incremental compiler, no problems.
Yeah. Okay.
It'll just take it'll just take all the classes together and says, I've got this class, I put it in a symbol table, it'll be okay.
Okay.
Yeah. So it won't occur.
Yeah.
Okay, so now I've got the interfaces. Now I need the implementations. And my implementation, I need, my counter value is going to be the same. Again, I'm not using inheritance. Okay? And so I duplicate the code for get value. My add value code is also duplicated, but after adding, I notify all observers. Okay, what does notify all observers do? It goes and looks at every observer. The observers have to be kept somewhere. We can have an indeterminate number of observers. So we have to put them in some dynamic collection. And I've just got this particular class that's an observable list. It's like a string history list that we saw earlier. And whenever you add an observer, you go and add an element to that list. Remove observer, you remove the element from the list. And notify all observers just goes through every element in the list and calls the update method on that element. Okay? And let's look at some interesting things here. I am not calling notify all observers in every method. I am not doing notify all observers in get value. Why not? It's not changing anything. Okay? It's only when the state changes that you display. So read methods don't go and call notification methods. Now, if you were tracking somebody's reads, okay, if Facebook allowed you to see who was viewing your page, then your read method would also go and update. Again, people have tried to build interesting tools around this idea, that whenever I'm browsing a page and you're browsing the same page, we can imagine both getting into a chat session, saying, do we really want to buy this product? Okay? Or what do we think about this, this PowerPoint that I'm seeing? So you can imagine some notification being done by read methods, but in our pattern, only the state changes are displayed in the view. So there's no state being changed. So the read methods don't update, don't notify, the write methods notify. And why did I call update here and add observer? So new observer just was added. Yeah.
So that observer can deploy somebody, because otherwise it's just going to know.
So it should display the current state. If the observer probably already has an update method where it does the update. We don't want to go and have that code in multiple places. So we put it in that update method. Now if observer was the one that added a cell, then it knows it can call it can do the update. But somebody else might go in added to the model, in which case it should know that it's been added. So it goes and gets the update. Okay? Questions about this code? Okay, my console view. So now how my console view just has the update method, no input, and all it does is, given a counter, it goes and displays this value. Okay? Just an independent piece of code doing output. And I can go to a JOPTION view, and that implements the same update method in a different way. It shows the dialog box. Okay? And this is interesting now. I said earlier that, interfaces combine the functionality of different implementations. And you can't see from the outside the differences between these implementations. But this is no longer true. I have two different classes doing two different things. One is showing something on a JOPTION box, one is showing something in the console, but they implement the same interface. Okay, so the interface is more general idea than how I first introduced it. It's a way to combine together multiple classes, which may do the same thing. That's not that can't be viewed from the those differences may or may not be viewed from the outside. Okay. And my console controller interface, I have now a set model, okay, that takes the model that I'm supposed to change, and here's my controller. It goes and basically reads the int and keeps adding that value to the counter. Okay, no view, no. So each of these pieces of code now becomes easier to understand. Putting them all together it's a bit of a challenge. Okay, and here's where we are putting them all together. So I create an observable counter. I go in, add to the model a console view. I create a controller. I create controller. I set the model of the controller to be me, and then I say controller.processing. Okay, that's my console main. My JOPTION main does exactly the same things, except that it goes and creates a JOPTION. Okay, and my mixed main. So this is the difference. The input code is all shared. And my mixed main, this is the most interesting one. I create one counter, and to that counter I add two observers, the console view and the JOPTION view. They're both viewing the same model. Okay? Same object is being shared. And I create one controller for both of them. Okay, so we'll stop at this point and continue. This is working. The partial ones are the trickiest things in life, always. Blank answer, correct answer, love them. Partially right answer. Did I take 2 points off here? Did I take 2 points off here? And these guys have different issues. Okay. So we said it's a model view controller pattern, and then there is an observer pattern that is a sub-pattern there. Okay, so if that's a sub-part pattern, then you should be able to have observers that are not views. Okay, that are not part of the model view controller. So can you guys think of observers that are not views? In an application? So somehow one model observing another model? Or maybe one view is observing another view. That could happen also. One controller could, yeah, sure. So that could be there, right? So supposing there were an indeterminate number of scenes connected to the parser, and the parser doesn't know how many different scenes there are. So the parser would just go and announce a change that, a new command has been entered, and everybody else around would go and respond to it. So it's not a best of examples. If you had multiple simulations running, let's say you had multiple models, each person had a different model, and then each model got updated. That could happen. Other examples? So the first time I taught this course, the students built something more boring, but something more challenging actually, a spreadsheet. And can you guys see how the observer pattern would be used in a spreadsheet? Whenever you have dependencies among models, okay, and the spreadsheet was a great example of that. Then what you had was that you had a cell, and that cell did not did not know how many other cells would depend on it, so it just fired the events, and the other cells got updated. Okay? And there's actually lots of cases where you have the observers. So one of my students did a PhD on using PDAs to interact with channels, with appliances, and to have a universal PDA actually, and there's a lot of user interface. In fact, he used object editor to automatically generate the user interface. There's a lot of interesting issues there. So he had to go and log events on a, that happened on an appliance. To what's, and so, you can imagine this kind of, anytime there's some kind of logging, I've told you guys about this Eclipse login that we couldn't get you in a nice state to use, but that would go and tell you if you tell somebody else that you're stuck, maybe. So that's, fortunately, Eclipse has an observer pattern built in there. So it allows its events to be monitored by other objects. And because it has that capability, we can write a little plugin that goes and monitors the act. Okay, so there's a good use of it. But if you're a privacy worrier, okay, then you probably worry about these things. Okay, so in the case of a counter, we can imagine an observer. Okay, a simple observer. So it's trying to see whenever the counter changes, and when the counter goes to 0, it does some action. Okay, and that's a model. There's no user interface being changed. It's just another model that is waiting. There's two different components, and that interact with each other. And our liftoff is just a print line. And but you can see here that there's an update method, just like the counter view update method being called, and that just goes and says if the counter becomes 0, then launch, and launch is just a little stop procedure. Okay. Now, just a little thing as you guys use the listener pattern. Notice that when the counter went to 0, two things happened. The counter view went and printed out 0, and the rocket observer went and printed out liftoff. And this happened in a certain order. Can you guys figure out why, what this order indicates? So if there are multiple observers listening to an event from an observer, in what order would those observers get the events? Sorry? In the order in which they're registered? Perhaps, most probably, because you probably store that in a list and you put it at the end. Okay? So that's what happens. You shouldn't depend on that. It's really a set. But if you're depending on that, then you make sure the registration happens in the same order. But don't depend on that. Okay? So what's really happened now is that I've got a controller, I've got a counter console view, I've got a rocket launching counter observer, and one is a view, one is not a view. And in your project, I'll try to add something. I'll try to, in your animations, if one animation should happen after another animation, okay, then maybe the second animation should be an observer of the first animation so that it knows when it's finished, so that it can fire things off. Okay, so I'll try to make something today that'll allow you to exercise this. Yeah, Sean? See, remember, I mean, you can do a lot of things. You've got full control as an observer. You can go and say, okay, this event occurred. Let me go through my list of observers. Let me make this a higher priority observer than another observer. But you should really, in a model, not be aware of who you're. In fact, you should be able to work without having any observers. That's why your parser example was not the best of examples, because the parser depends on the scene being around. Otherwise, it's a useless thing. Right? So whereas this counter could be a useful thing without there being any observer, because somebody goes and puts a value in, somebody gets a value out. So, but you can do all kinds of things. Okay. But the way our program was written, we said notify all listeners, It went through the list and notified everyone. And you didn't say notify these guys. See, notify all listeners is called, and whenever notify is called, both observers get notified. So when the counter changed, you did notify all listeners, so it didn't matter whether you did it, if you did notify all listeners before you changed the counter, you shouldn't have done that, okay, because you haven't changed. But if you did, both observers will see the same value, which is the old value. When you do it later, they both see the latest one. Okay? In what order they'll see it, because things are going sequentially so far. Today we'll learn how not to do things sequentially. Okay? Then that's different. Then it's one could get it before the other. But notify all listeners, notifying all listeners in some order. It's not just going, at the same time. Okay, so that's what really happened. Okay, and this is my main. Now I've gone and composed my model with multiple observers. Okay. You've got the basic concepts. Now we have to implement these, and so we need to know some details, which also have some concepts behind them. So our update method, we could call it update, we could call it notify. So that's an issue. Should we have a standard name, or can we just choose whatever we feel like? Okay. And that update method takes as an argument the observable. Okay. And there's a question as to what exactly is the list of arguments to this method. Should it have any argument? Should it have more than this argument? So let's go and try to first be minimal. Can we, in some situations, get rid of the observable argument? And we answered this question last time, just to sort of do this, we'll just review that. Does it make sense in some cases to not pass that argument? So how would the update method know which model it should go to or which observable it should go to? How did the controller know what model it should go to? You call in the beginning a method in the controller saying this is your model, your one and only model. So if the observer has one and only observable, when it started up, it could be told this is yours. It could be passed as a constructor argument or whatever. And in our example, that's what really happens.
But it can change, right, in the future?
If it can, then we need this. Okay. So I'm just telling you that they're just details that sometimes, often it doesn't change. In our example, it doesn't. Okay. So if it can change, then we need different. Do we need more than one argument? Okay, so we're trying to be very flexible and maybe want to be efficient also. Does it make sense to have more than just the model as an argument? Just the observable as an argument? So the update method says, I've changed. That's all it says. This is me, and I've changed. What else could it tell the observer? So from a counter, it says, I've changed, and it goes and gets a new counter value. What else could it say? Okay, if the model could say, I've changed, and this was the time when the change occurred. Okay.
I mean, I'm just trying to think. Inside of that, you kind of use an interface, and all the methods and all the things that you want any other class to know are knowable just from that instance of model.
Yeah, you can always find this information, but the time of the change is not something you can get to know. So maybe the model does, in fact, record the time, and say this is when the change occurred. Okay, the update method could also record the time, but some time can pass. If there is 1 million observers, by the time it gets to be the last one, a lot of time has passed. By the time its update method is called, a lot of time has passed. So time could be, yeah?
Is it possible for one observer to observe two observables and then update whatever it needs to update?
So that an observer can, in fact, observe two observables, and that's why we pass this as an argument. If the observable changes, or if there's more than one observable, we pass that as not.
So would you have two observables within the argument of update for specific
So-
observer then?
So the update came from one specific guy, right? They don't coordinate with each other. So you will get one update from one observable, you get another update from another observable. At any one time,
Okay.
there's only one observable that changed. Yeah.
Well, like you said earlier, if you wanted your update to do something different depending on what kind of pattern it was observing, you might want to have another parameter.
Another parameter that says what kind of counter it is. So you're saying this type doesn't really describe it.
Well, if that's the most general thing, you know.
You can do instance of and find out what exact type is, the exact type. But you might have two observables which are the same type, but one is my Facebook entry and another is your Facebook homepage, and they're both the same type, and it could perhaps provide a string, which may not be. I mean, that string is something you can probably get from the object through a getter. So in general, that may be useful, but typically you will have some method in the object itself. So let me just go to the next slide that shows you. This is what I was talking about earlier when you don't have any argument. So at some point there's a method called setObservable that's called, and then you just assume the same thing. Now let's go back to having more than one argument. Supposing my observer is in China, and my observable is here. So I'm the counter here, and there's a view in China showing the liftoff. Okay? So what do? I go and tell it, I've changed. So a long distance call is made to China. What does the view in the China do? Update. And what does it do then into update? What does update do? It sends it back information, or what? If you remember the view, what did it do? It went and. So how did it know the new state? So what does the counter view do? In the update method, it print lines what? Give me the whole thing. Count. How does it get the new value? No. It got back a counter. What does it do? How does it get the counter value from counter? It got an object called counter. It needs to go and display an integer. How does it get the integer from the counter? Sorry? Counter.getValue, right? So what happened? I sent a message to China saying I've changed. One call made, one message sent. Then it goes and sends a message back to me saying, what is your value, by the way? Okay? I say the value is 5. How could I make that more efficient? Passing the value as a parameter. Okay, so this is the distribution issue. Imagine this is distributed. So, okay, exactly the example I was talking about. And update must make a long distance call to read method getValue to update counter state. So we could go and pass to update the new value. Okay, you say, I know I'm just a counter. There's only one thing of interest in me. It's a very small value, so I'll just pass it to you in the method. So just we make only one call. We don't make 2 calls. Okay, and this really can be slow in the situation I've talked about. Okay? So you don't need to call a method in the object, in the model. And in fact, there is something called in the Java.UTIL library package. There is exactly an observer interface which has these arguments. So the observable is a class that Java defines, just like our observable, and that is what which counter changed, and this is by how much it changed, or what it changed. Okay, and by how much, so you've got this basic use here, and sometimes you want to know by how much it changed, which is what I said. So rather than sending the counter value, you could send the difference, some delta, something that describes the difference between what the old state was and the new state was. So you can go and take that diff and just apply that to your view rather than go and recompute the whole view. Okay? And in fact, and the nice thing here is that if you didn't pass this increment, the observer will have to keep track of the old value and the new value and do the diff itself. Whereas here the difference is the responsibility of the model now. It's got to do more work. But then, one class does all that work, not every observer class. Okay. And in fact, you can be even more flexible, that sometimes you need the absolute value also and you need the diff. So you can pass basically the old value and the new value. Okay, you can say this is the old state that you may be interested in, this is the new state, and you figure out, observer, whether you want the full state or you want the difference. Some observers may be lazy, they don't go and compute differences to update the display, they will go and just redisplay the whole thing, and some may be smart. And so this way you can accommodate both kinds of observers and do this. So I'm just giving you slight variations on the basic concept of having an update method. So again, observer interested in change does not need to keep old value to determine change, but the observable does. So this is what I'm saying. You can accommodate both kinds of observers, and so this is nice. But it makes observers harder to code, as you will see when you guys do your coding. Okay. Here's something else you can do. You may be sending the old value, the new value, the diff, the time, who knows what information, and you don't know which observer may like what information. Okay? So it's really, you have a lot of observers, and different observers may like different values. So what you do is, rather than having a whole long list of arguments to your update method, you just have one argument. Okay? That one argument is not a simple value, it's an object which has the source, who changed, the old value, the new value, the time of change, or whatever. Okay, so you can have one such object. So what do you guys think? Would you like to have, so you're now saying update event. An event is now this type, that is a composite type, it's an object which has got these fields of properties. So would you guys like to pass one object, or would you guys like to pass different parameters for the different values? You like this? Why? So what happens now is that event has got these methods. This event is a composite object, so it has now methods called, get counter, what changed, what is the old value, what is the new value. So you think this is easier to read? Any other advantages, disadvantages?
One of the annoying things with parameters, I guess, is that they're very order dependent. With this one, you sort of eliminate that because you're only passing one event instead of three different things. You can easily get the new and old numbers mixed up.
So you might go and pass you might get, both of them are int, so you might get them switched. So this is nice, that's a nice argument. Whereas here you'll just go and say set, you'll have to go and do a set on this event before you call it, and it doesn't matter in what order you do the sets, it'll all work. Okay, other
You can also add additional logic, right? By having to maintain or update this attribute and always specify that.
You're saying one event may cause another event to occur. That can occur in both cases. This is just syntax. You're getting the same notification, is whether you get that in multiple parameters or a single object. Okay? But you're right in the following sense, that if I'm going to forward, I just have to forward one object to another guy, rather than, which is what this thing is saying, rather than go and collect all the parameters and then pass them as parameters to another guy. And then I can make a mistake again. And trust me, I've made such mistakes. Okay? So it's nice to just have one object that's encapsulated rather than have to send things around. And you can add a lot of stuff to that object that only a few observers would care about. And what will happen to the normal observer? The normal observer will say, here's my event, tell me the old value, and that's all I'm interested in. It doesn't even know what other properties exist. It just gets out the things it's interested in. Okay? So it's easier to understand in that sense. So callee does not have to declare parameters for event information fields not of interest. It doesn't even have to know about them. There are these objects that Java supports, and honestly, I don't know how they're broken up, all the fields in it. I just go and extract what I care about. Okay? And the caller can also not have to fill every value. It can just put nulls in things it doesn't want to send. So it says somebody wants his time, it says, I'm just going to pass null. Okay? So I won't even initialize it. So we can just, we can define this generic type and use only those aspects that are really needed for that application. And this is something that you see actually in toolkits. So if you ever use the AWT or Swing toolkit, you probably use this event. Anybody seen this event before? What is this event?
I think it uses it in component when you use buttons, and when you click it, you have a listener who sees the button is clicked and does whatever it has to do.
So it is a very generic event. In a button, it means the button got pressed. In a text field, it means you press enter. Okay. So the action event is something that's common to all of them, and it's got a field called source, which is who sent the event, and you can get the time and all that stuff. So I'm just leading you towards what you see in practice in real software. So when you edit text and hit return, this event sent by text field widget to its listeners, such as object editor. Okay, that's how object editor is implemented. And again, with buttons, the same thing happens. Okay, so we seem to be understanding things well in depth. So let's go back to a BMI spreadsheet example. Here's my interface: get height, set weight, get BMI. Now tell me which methods need to notify. And I want to make this into an observable BMI spreadsheet. This is my regular BMI spreadsheet. I want to make it into an observable BMI spreadsheet. If I'm going to do that, I have to notify. So before we figure out what the exact nature of notifications is, let's try to figure out which methods need to notify. So does get height need to notify? Read method, right? So only the set methods need to notify. So set height, what should it send out? So we have an update method that takes 2 arguments, old height, new height. What about set weight? So what method is called in that case? So I have one update method that takes 2 parameters, old value, new value, and both get height and both set height and set weight call the same method. If they did, how does the observer know which one changed? So you could have another argument that says what aspect of your object changed. Okay? You guys like that? Yeah, so let's try to figure out what information needs to be sent, then we can sort of do it as an event or a... So what is the observer interface? And one simple approach is you just have update with BMI spreadsheet being sent, okay? And whenever either the height or the weight changes, you just send the BMI spreadsheet. What's wrong with that? That's more uniform, just one method. So you've got you're sending stuff to China and you've got a big object. You're sending the whole object. Okay, and the other party has to figure out what changed. Okay, so that's kind of complicated. That's kind of inefficient. So this is coarse-grained update. Okay, so each setter sends the whole object, and observer must determine which property changed. Okay. So you can do exactly what. So you can do instead have multiple methods: update height, update weight, update BMI. Okay, so you don't have to have a single update method in the observer interface. You could have different methods. Okay, so now I can differentiate between height, weight, and what changed, whether the BMI changed. And so this is another solution. So do I need an update BMI? Will the BMI change each time the height and weight change? There can be some rounding thing. You might change your weight by like 1 ounce, which may not change your BMI. So where will update BMI be? So your setters will have to do that. Your setters will have to see that, did the BMI change? And if so, they go and send the update BMI. Yeah, of course, you could be a little inefficient and say, look, I'll call update BMI each time, or whenever update height or weight is called, we'll just recompute anyway. But this is the sort of more. So you can have multiple notifications in one setter. Okay. Now this is one approach, which and here's another approach, which is the approach that you were suggesting. Okay, so you take update BMI spreadsheet, string property name, object old value, object new value. So which do you guys like better? An interface with multiple methods, or an interface with one method with all these extra parameter? This one? Bo?
I like the other one just because I think it would be for more methods to benefit.
Actually, that's a very good rule of thumb. More methods, the better. That's a very, very good rule.
Like you're saying, with this setup right here, it's really hard to tell what changed because you're just passing everything down.
No, but you're setting the property name,
I guess,
but you've got to go in.
you got to go and check and see what it is, and the methods take care of that for you very nicely.
So you've got to go and check what property it is. Every time you add a new property, you've got to go change this method. Whereas there, you just have to go and add that one method, and you don't have to worry about this dispatching method. Okay. Plus, what if you change the property name? Okay, so let's go and see its use here. So what if I go and make this, accidentally make the mistake and call it WGHT rather than WEIGHT? Okay, it's the kind of stuff that you guys might have done when object editor was giving you trouble. Okay, suddenly this guy says, I don't know what property you're talking about. Okay, so why did you like this? Just because Java has it? It does, but no, you have to figure out in your, if you use this is very Java inspired. Okay, so just because Java has it, as we've discussed many times, it's not the right thing necessarily. Though I will tell you later this is the right thing to do. But so far, I mean, the arguments, the nays have it. You have to go and do all this checking. It's a pain. You make the mistake of typing the wrong property name. It's a pain. And by the way, you guys will have to use something like this. Okay, so you will suffer this pain. Okay, so is there any advantage of this? Okay, you can also sort of, this takes object as an argument. You can go and pass, rather than the value 1, the object 1, and again, because this is a very generic thing, you can make all kinds of mistakes. You can either write 5,000 methods, or you can have 5,000 if statements in this method. You can't get away from that. Unless you don't care about the property name and you just say, I'm going to update the whole thing. And that's a good thing. A lot of object will say, I don't care what property changed, I'll just redisplay everything, so I don't have to know this. Okay. So new methods not needed as new properties added. I mean, this has that idea, but you need new cases. And the different setters call the same update method with different types of values. And you can use this for arbitrary property values. Okay, this is sort of the good things. But the bad thing is you can make mistakes and must process property name to determine what changed. Oh, I didn't get my spelling right here. Yeah.
So I'm a little bit confused. Say you have a method called update.
Yes. Like we did in the previous slide.
I understand that you could pass a BMI spreadsheet as a parameter and then use the getter method.
Okay, you can always do that. You can always do that.
You could pass, the int for the old value and the int for the new value, but I don't understand why you would do both.
Okay, so there's two dimensions here. Okay, one is, do you pass the whole BMI spreadsheet, or do you pass components? Okay, and there's pros and cons. And if you've got lots of properties and only one change, you don't want to send to China this whole thing. Okay, if you're going to pass components, this is a syntactic issue. Should you have a separate method for each component, in which case the interface becomes this long, or should you have a single method for all components, in which case your if statements become very long, in case you distinguish between properties. Okay? So whether you send the old value or get value is independent of whether you have one method or multiple methods. Even in the update height, I send the old height and the new height.
Right, so if you send the old height and the new height, then why do you need to send
the name?
BMI spreadsheet?
Oh, just in case this, why am I sending this?
Yes.
That's a good point. I don't need to. If this guy is bound to a particular model, but if this guy is a generic view that can have, multiple models, then it needs to know what model was sent. Okay? And by passing these guys, I get to know what part of the model changed, so that I don't have to go and do diffs between the old model and the new model. And when I send it to China, I can just send a kind of reference to the model. I needn't go and send the whole model. I get into distribution issues here, but you can just pass a little reference saying, by the way, this is the model, without you sending all the data. Okay? So that's a good point. So, we still haven't quite figured out why we should have only one method. But I'm just showing you how this one method works. So now what you would do is, you would go and say in set height, you would, before you change the height, you would say old val equals height. Okay, so you're recording the change. Then you go and make the change to your height. And then you say notify all observers. You go and pass yourself because, the view might have multiple models. Okay, you go and say, look, height changed. Here's the old height, here's the new height. New val was my argument. So new val works. I could have even said height. Okay? And notify all observers, goes and says update. And it now takes a string as an argument, which is which property changed. And it goes and says property name, old value, new value, which are passed as an argument to this. So I'm just showing you how this works so that you understand. And this is, like I said, this is what you will be using, even though it seems this is all, much more complicated than it need be. Okay? And this one is a BMI observer, okay, which has its update method. Okay, so you guys understand at least how this is working? And like I said, you can make mistakes.